The last section in chapter 5 is the average value of a function. And overall, it's quite a straightforward idea. This is the definition here. It is the idea of the mean value theorem for integrals. And all it says is that there is some y value and moreover some c value such that it is equal to 1 over b minus a, which is simply the length of the integral, 1 over the length of the integral from a to b f of x dx. And it's what's considered the average value of that function, the average value of the function. So let's look at it graphically. So this is visually what it is, which is kind of interesting. It's the height of the rectangle that equals the area under the curve. So that's actually kind of a cool thing here. So you have your area under the curve, which is all of this area under the curve. And what you can do by doing the formula that we saw on the last slide is there is some value c for which when you find c, then the height of it gives you the area of this rectangle, and the big point of it is that both of those areas are equal. So the area here equals the area here. So when you find the average value, you actually find some f of c, that's some y value. And then you're able to, from that, solve for the actual c value. And that's the average value. So this is, very similar to some of the other stuff that we saw in chapter 5. So what's happening here is it's saying that the average value is literally the idea of the average. And so it's taking a bunch of y values taken at different sampling points of the function and dividing them by n, by how many are being taken. But remember that delta x is b minus a over n. And so if you do a little bit of algebra here, you of course find that n is b minus a over the change in x. So that's what you see here. And then what's happened is they've taken and pulled out the 1 over b minus a, so that's what's right here. And then because it's dividing by the change in x, that's multiplying, it's dividing by 1 over delta x, which is the same as multiplying by delta x. So you get this, and then of course the idea is if you add up an infinite number of that idea, then that would be this integral right here, because you'd be adding up an infinite number of them. So similar to that. So that's just kind of the derivation of it. Not the full-on proof, but just like where it comes from. So we're just going to take a look at a couple examples. This section is fairly straightforward, especially compared to what we've seen. So in order to find this idea, all you have to do is do your b minus a, which is 3 minus 0, and that's 3. And so the outside of your integral is 1 over 3, the integral from 0 to 3, and then whatever your function is, x squared plus 4x plus 1. And then you just integrate and then multiply by 1/3. That's the whole thing. So that is f of the average value of f. So if you want, you can pause and find an answer, and then we'll go from there. So I take my antiderivative, And then I'm just going to evaluate. Evaluating at 0 is going to give me nothing, so that's helpful. So I have 1/3, and then I'm going to plug in 3. So 3 cubed is 27, divided by 3 is 9. And 3 squared times 2 is 18, plus 3. So it looks like we have 21, 30. And so we get 10. So the idea here is we can find 10, that's the average value of the function, and then the idea here is we can think about it like this, that by choosing 10, what we have found is the y value for which the rectangle that's created from it has the same amount of area underneath it than area under the curve from 0 to 3. So we've got it. I'm just trying to make it better, but it's very hard to draw a straight line on the tablet. So we have that. So our answer here, the average value equals 10. That's the first part. Second part says find the actual value of c so that f of c is f of average. So what it's asking us for now is to find this c value, if we go down here, for which f of c equals the 10. So all we have to do is do f of c, which is c squared plus 4c plus 1, and that equals 10, and then we just solve this for c. So you'll notice that this is quadratic, so 4c minus 9 equals 0, and then all we have to do is solve it for c. You probably noticed this does not factor, and so you're going to have to do something else. Because it's quadratic, the easiest thing is quadratic formula. So take yourself back to your algebra days. So the solutions to a quadratic equation are taking the coefficients of the different variables there. So you're going to have negative b plus or minus the square root of b squared minus 4ac all over 2a. And I know I'm saying c, it's not the same c, I'm just using the quadratic formula in its typical, the way it's typically said. So we get 16, it looks like plus 36, so that's going to be 52 over 2. And that can simplify a little bit. 52 is, that has perfect squares in it. Just going to make it a little bit shorter so I can fit everything. Okay. So negative 4 plus or minus the square root. So it looks like 15 is 4 by 13. And so I haven't really helped myself there. There we go. And so 4 times 13 under a square root is 2 root 13 divided by 2. And so you can see that you can do a little bit of simplifying here. You got to have it in all three factors. So you're going to get c equals negative 2 plus or minus the square root of 13. Now obviously one of those values is negative, and we're just going from 0 to 3. So our value, I'm going to bring it over here, will be negative 2 plus the square root of 13. And that is about 1.606. So now we have found that c value. So what we find is that f of 1.606 should be about 10. And more importantly, that value that we found is what then creates the average value. And the whole point is this area that I'm shading in the dark blue pen is equal to the light blue shading on underneath the curve. So that's all there is to it. So if you want, you can see if you can get the answer to this one on your own and then come back and see if you are right. So the setup is 1 over b minus a, and then we put our function inside. I'm going to raise it to the 1/3 so that I can take the antiderivative easier. Now, something to think about here would be, technically this does require the substitution rule, simply because the derivative of the inside of that is not just 1. The derivative of that is 2. So it's a fairly basic substitution, but it would be a good idea to use substitution here. So I'm going to make u 2x minus 1. So du is going to be 2 dx, or dx is going to be 1/2 du. Now I can also change my limits of integration if I want. So when x equals 1, u equals 1, so that's not too exciting. When x equals 14, u equals 27. So now we'll write this out. We have 1 over 13. I'm also going to have that 1/2 that's coming from the rewriting here using the substitution. Oh, I lost my 1 there. So we're going from 1 now to 27, and I have u to the 1/3 du. So again, using the substitution method. So that will give us 1 over 26, and I can take my antiderivative at this point. We have u to the 4/3, and then dividing by that multiplies by 3/4, and we're evaluating that from 1 to 27. So it looks like we'll have 3 over 104, and then we are evaluating u to the 4/3 at 27, which u to the 1/3 will be 27 to the 1/3, which is 3. 3 to the 4th is 81. And then we put in 1 to u to the 4/3. That will just give us 1. So we have this, and if you evaluate that, you'll get 30 over 13. So not an incredibly quote-unquote pretty number, but that is the average. I'm going to put it as a decimal, 2.308, just to show you where we're at. So 2.308 is somewhere here. So that's the idea, is that we've now found that average for which the created rectangle. So notice your page will have 2 different graphs, but I'm just doing it on the one. So we have something like that. So it's, saying basically this area is approximately equal to this area here. Mine looks not quite what it should be, but that's the point. And then now we just need to find out where that happens. What's the C value? So if we do f of c equaling 30 over 13, that will be, we just put in c, so we're going to have the cube root of 2c minus 1 equals 30 over 13. Now, in order to get rid of the cube root, we need to cube it. So that's going to give us 27,000 over 2197. If we add 1, this actually simplified is 29197, which makes sense because you're basically just adding 2197. over 2197, and then we divide by 2, and we get 29197 divided by 4394. So, you know, it is what it is here. But we can change that into a decimal, and we'll get approximately 6.645. So looking at what we've already done here, that makes sense, you know, that's going to be somewhere around here. You know, it's not perfect, but we're just estimating it here that this is our C, here's our f of C. And so what we have found is that the average is 30 over 13, and C is 29197 over 4394. So that is all there is for the average value of a function.